We need to determine the sum to n terms of the following series. Let us begin. Now first, what our goal will be is to determine the rth term of the series. We're going to represent the rth term as TR. Now the rth term of the series, we will define it as, so we'll consider each terms in the numerator. So starting from 1, we have the next term is 2, the third term is 3, which means that the rth term of the numerator will be simply r. Now coming to the denominator, we see here that the first term of each of the denominators stays fixed. So that's going to be 1. However, if we look at the second term, then we have 1 squared in the first term, 2 squared in the second term, 3 squared in the third term. So that means the rth term is going to be r squared. So this was going to be added to. Now we see that the third term in each of the denominator is 1 raised to the power of 4, followed by 2 raised to the power of 4, 3 raised to the power of 4, which means that the rth term is going to be r raised to the power of 4. So this is going to be the rth term of the series. So here we can write it as r divided by 1 plus r squared plus r raised to the power of 4. Now, what we have to do, we'll have to decompose this fraction into two partial fraction. So this is going to be given by, now what we do, we are going to first factorize the denominator. So here we have r divided by, in the denominator we have 1 plus r squared plus r raised to the power of 4. Now clearly this is a biquadratic form. So when we factorize it, we are going to get the factors as 2 quadratic. So we have 1 plus r squared multiplied to 1 minus r plus r squared. Fine. Next what we'll do, we will decompose this, and when we decompose this, we are going to get half multiplied to 1 over 1 minus r plus r squared minus 1 divided by 1 plus r squared. So this is going to be the rth term of the series. Now that we have the rth term, we are ready to obtain the nth term of the series. However, before continuing, let me give you a quick hint how to get this particular result. I mean, how to get this two partial fraction from the single fraction. We can use the method of partial fraction. So we can use the method of partial fraction. We can rewrite this fraction as ar plus b divided by 1 plus r squared added to cr plus d divided by 1 minus r plus r squared. All we have done is decompose r divided by 1 plus r squared multiplied to 1 minus r plus r squared into the two partial fraction. If we solve for the value of a, b, c, and d, we're going to get exactly this particular result. Okay, so let's now try to find out the sum to n terms. The sum to n terms will be given by summation r going from 1 to n. We need the rth term, so that's simply going to be half multiplied to 1 over 1 minus r plus r squared minus 1 over 1 plus r squared. Now we'll be expanding this particular series. For the first term, all we have to do is replace the r value with 1. So that's going to give us half multiplied to 1 minus 1 over 3. Added to half multiplied to find out the second term, we're going to replace the r value with 2. So that's going to give us 1 over 3 minus 1 over 7. So this is going to continue all the way up to the nth term. So that is going to be, we have half as the common factor, 1 over 1 minus n plus n squared minus 1 over 1 plus n squared. Fine. Now this is going to be equals to, now what we can do, we can take the second term and then cancel it out with the third term. Fourth term and fifth term will get cancelled out. Similarly, the second last term will also get cancelled with the third last term. Finally, that leaves us with half multiplied to 1 minus 1 over 1 plus n squared. Okay, so let's combine them. So that's going to finally leave us with n squared plus n divided by 2 multiplied to n squared plus n plus 1. Fine. So this is going to be the sum to n terms of a given series.